Okay, so here's the equation we're trying to solve. And notice we've got a square root. How do we solve an equation in which we have a square root in the problem? What do we do about that? Well, again, I put this in the notes for you. If you come up here, here are the exam number 1 notes that I made for you. This is in the Unit 1 module, right at the top of the Unit 1 module. And so I would say solving a square root with only numbers on the other side. And then in a minute, we're going to do one with x's on the other side. So when you have only numbers on the other side, what do? This is our exact example. Get the square root alone, parentheses second power both sides, and the second power cancels out the root. That's what we have to do. All right, let's do it. So step 1, get the square root alone. So have you noticed this is pretty much what we always do? We're always getting the whatever alone, aren't we? We're getting the x squared alone, or the weird power alone, or the absolute value alone, and now the square root alone. So I hope you're seeing the pattern. It might seem like there's 27 different things we do, but really they're all very, very similar. When you have some weird piece, whether it's absolute value or square root or 7/3 power, some parenthesis power thing, you basically get that thing alone. And then you get rid of the absolute values or the square root or the weird power somehow or other. That's generally always the game plan. Get the weird thing alone and then get rid of it by some other power usually. All right, so let's get the square root alone. So to do that, here's our equal sign with the 2 sides. So we're going to subtract 10 from both sides. Get 15 over there. And then we're going to divide by 5. Okay, so there we go. We got the square root alone. That was all step number 1. We just got the square. See how the square root is all by itself on the left side? It's all alone. That's step number 1. That's what it says up in the notes. And now, step number 2, we're going to go parenthesis 2 power both sides. Because that is what gets rid of a root, right? Do you see the game plan where we always get the weird thing alone and then we get rid of it? Well, how do you get rid of a root? What's the opposite of a root? A 2 power. Whatever you do to one side, you have no choice but to do the same thing to the other side to keep the balance. Are you tracking with me on this? Are you starting to see the patterns here? Whenever we have a root, we do a 2 power and that cancels it out. Or if we have a 2 power, we do a root. They always cancel each other out. In fact, that's what I'm going to show right now. This root and this 2 power, the root and the second power cancel each other. So we get the root alone and then we get rid of it by doing a 2 power. So what does this give us? X plus 2 equals, and on the other side, 3 squared is 9. Right? Because that just means 3 times 3. Why didn't things cancel on the right side? Well, there's no root over there. Huh? See over here, there's no root here. So that 2 power is not going to be canceled. You're going to have to actually do it. You're going to have to do 2 3s. 3 times 3 is 9. Whereas over here, the 2 power was canceled because there was also a root. It's like a poison and the antidote, right? They neutralize each other. So on the left side, nothing really happens because the poison and the antidote cancel each other. The 2 power and the root cancel each other out. So you don't end up rooting or 2 powering. They just eliminate each other and you just bring down the x plus 2. But on the right side, you got to do the 2 power. because there's no root to cancel it out. All right, so the hard work is over. Now step 3. Solve for x. Solve for x. So now we just subtract 2 from both sides. And we've got it. X is 7. X is 7. Okay, yeah, now there's one special step, though, that I need to tell you about here. Let me write that in. Any problem starting with a root, like that was this one, right? See how that was the start. It's starts with a root. Any problem starting with a root you must check your answers by plugging into the original. So you got to go back to you got to take this answer and check it. You've got to check your answers. The reason is you can actually get false answers. So let me grab the original. I'm going to bring this original right here. I'm going to bring this all the way down. What was it? It was a 10 plus 5 root x plus 2. And all the way down here. 10 plus 5 root x plus 2. What was it? 10 plus 5 root x plus 2 equals 25. So you've got to take that and you've got to take this answer of 7 and right there you got to plug in and you got to see if it works out. It's quick, it's easy to do, but you do have to remember to do it. So 7, just plugging in 7 there, because that's what we think the answer is, right? We think the answer is x is 7. Let's see if that's right. So what would that be? 10 plus 5 squared. 7 plus 2 is 9. So you just work out the numbers. You can probably just do it on your calculator. 10 plus 5, what's the square root of 9? 3. Just do that in your calculator. That's 10 plus what? 3 times 5 is 15. And that's 25. Yeah, look, it works. Checks. So it checks. So the real answer, that x equals 7, is the true answer. So you have to check them. Any problem that begins with a square root, you have to check it. You do have to check your answer. So x equals 7 is the true answer. We checked it. It's really right. It made the original equation true. That's what an answer should do, right? Make the original equation true. It did. It's right. The original equation is true. So how do we solve square root equations? Step 1, we get the square root alone. Step 2, we parentheses square both sides because the 2 power cancels a root. Then you just solve for x, but you must check any problem that starts with a root. You can put that in your notes, and you need to check any problem that's starting with a root to make sure it's really right. There we go.